vCloud Director, or VCD, is an infrastructure as a service cloud that enables the consolidation of virtual infrastructure across multiple clusters, the encapsulation of application services as portable vApps, and the deployment of those services on demand with isolation and control. VCD abstracts the user or cloud tenant away from the underlying vSphere resources into logical constructs at the cloud provider layer and cloud consumer or tenant layer. While VCD can pool multiple vSphere clusters into a single logical pool of compute resources, for simplicity in this example, we are going to look at a single cluster. In order to run the tenant workloads, VCD consumes ESX clusters in the form of their resource pools and distributed virtual switches for dynamically creating network connectivity for the vApps within the cloud and across the border of the cloud to your corporate network, WAN, or the Internet. We'll call this the infrastructure layer. Above the infrastructure layer, we abstract the virtualized infrastructure into logical cloud objects. The compute capacity, or in other words, the resource pool of an ESX cluster, or clusters, are abstracted into the provider virtual data center. Nothing new is created in this step. This is simply a logical operation whereby VCD takes ownership of the resource pools. VCD also abstracts the distributed virtual switches and their associated port groups into provider networks. We also have the notion of a network pool, which is a way for VCD to dynamically create and assign Layer 2 networks to organizations within the cloud and their vApps. Network pools are delivered either using network isolation techniques that are enabled by vCloud Director itself, pre-creating port groups within the DVS, or you can isolate your networks using VLANs. It is at the provider layer where the party delivering cloud services manages their capacity. Above the provider layer is the tenant or consumer layer. When we onboard a customer into our cloud, we first have to create the logical container within which they will exist and be isolated from all other tenants in the cloud. In this case, we're talking about a private cloud, so we have two business units from the organization, HR and R&D. Once we create our organization, we need to bring our users into it. VCD can authenticate users against your existing AD or LDAP directories, or manage organization users locally. Users are assigned roles within their organization, which controls what they can and cannot do as a tenant of that organization. We now have an organization with users, but in order for the users to run their vApps, they will need a place to do it. The provider assigns capacity to the organization in the form of organization virtual data centers. The organization virtual data centers are created by assigning capacity from the provider virtual data center to the organization that is going to consume that capacity. There are three allocation models by which the provider can assign capacity. Allocation models control how the resources are allocated to a vApp and where the control of overcommitment of the resources lies. In the allocation pool model, the provider controls the overcommitment level of the underlying compute and memory resources. An organization VDC may have 100 gigabytes of RAM assigned to it, yet it is only guaranteed at 50%. The end user has no control over the commitment levels. Once 100 gigabytes of RAM have been allocated to a vApp, the user will no longer be able to deploy additional vApps. In the reservation pool model, when the same 100 gigabytes of RAM are assigned, they are guaranteed to the organization at 100%. They are pre-reserved for the tenant, and the tenant controls the overcommitment of the resource. If the tenant wants to run 100 gigabytes worth of vApps in their organization VDC, they'll have zero overcommitment. They can also run 300 gigabytes worth and overcommit themselves by 200 gigabytes. The tenant is in control of overcommitment. In the pay-as-you-go model, overcommitment is controlled by the cloud provider. However, rather than assigning capacity to the organization data center from a CPU standpoint, the pay-as-you-go data center has a provider-specified virtual CPU speed, and regardless of the physical processor spec, the VMs within the vApp will run at the provider-specified speed. Once we have a place for our vApps to run, we need to provide them connectivity so they may communicate with one another and out of the organization's border to external systems and users. The provider does this by assigning organization networks to the tenant. A private network within VCD is dynamically created by consuming a network from the network pool at the provider layer. VCD creates and isolates this network so it is completely private to the organization. Network pools are assigned to the organization, and it's from this pool that network will be created. We also require networks that can communicate out of the organization to our users or external services. Organization networks with either direct or routed connectivity are created for this purpose. The org direct network has no isolation between the organization itself and the external network it is connecting to. It's important to note that in this case, the NICs on your virtual machines in the cloud are being directly connected to the backing physical network that is connected to the distributed virtual switch at your infrastructure layer. If the tenant requires the network to be isolated from the external network, a vShield Edge appliance is deployed on the border of the network in order to provide firewall services for that network. Traffic can be network address translated or routed across the edge device in order for vApps to communicate on the external network. Our tenant now has compute, memory, storage, and connectivity in their organization within the cloud. The last piece to the picture is the service catalog, where we can store and deploy virtual applications from. A vApp is a virtual application that is comprised of virtual machines, their associated networks, and any embedded policy metadata required to deploy the virtual application. The vApp itself is based on the Open Virtualization Format, or OVF. In its simplest form, a vApp is a single virtual machine, and the vApp container. Whenever deploying VMs to VCD, we always deploy a vApp, whether it contains 1 VM or 20. In this simple example, we have a vApp containing a single virtual machine. A more advanced vApp may contain several application tiers, with web servers, middleware servers, and backend databases, all packaged as a single virtual application for deployment as a single instance. The vApp can contain private layer 2 networks to interconnect the virtual machines that will be created on demand by VCD when the vApp is deployed. It can be isolated from the organization network by a vShield Edge appliance that is dynamically created and configured based on the vApp policy. We can also store key value pairs of metadata with the vApp or the VMs within the vApp for consumption by other processes or our cloud orchestration layer. The cloud user can deploy via the VCD GUI or programmatically via the vCloud API. A vApp is deployed from the service catalog to the appropriate virtual data center. In turn, what is happening is that the vApp is consuming capacity within the underlying provider virtual data center. This provider virtual data center is ultimately capacity within a resource pool on an ESX cluster. This has been a quick introduction to vCloud Director and how it abstracts vSphere resources into an IaaS cloud.